Hello once again, dear students. Today we are going to discuss the lessons for week 5 for the second quarter. So we start with part 1, which is the laws of exponents. This is teacher Mary Jane. Here is our most essential learning competency and our reference. For our review, let us identify the parts of the exponential expression below. If we are given 5 squared, we know that 5 is called the base and 2 is called the exponent. And when we expand that, we will have 5 times 5 or 25. We will learn more on that later as we discuss our lesson. Here are the different laws of exponents that we are going to learn. The power rule or n times, the power of powers, the product of a power, the quotient of a power, the law for zero exponent, and law for negative exponent. So let us start with the power rule or n times. For the power rule or n times, let us look at the following examples. So we have the expression 2 squared. And when we expand that, we will obtain 2 times 2. For example number 2, we have the expression 3 cubed. And when we expand that, it can be written as 3 times 3 times 3. And how about for the next example, we will do the opposite. So if you are given 5 times 5 times 5 times 5, how do you think, or how can we write that as an exponential expression? So our base will be 5, and then our exponent is 4, since we are multiplying 5 by itself 4 times. Similarly, let us do the same thing for example number 4. So we have a times a times a times a times a times a. When written as an exponential expression, it can be written as a raised to 6. With that example, what did you observe? How did we determine the base? And how about the exponent? So to answer that, we know that the base, again, refers to the number that we are multiplying to itself, and the exponent refers to the number of times we are multiplying the base by itself. So that is power rule. And for the general rule, we can say that a raised to n is equal to a times a times a times a. So a can be any number or variable. At the same time, n can also be any number or variable. For the second law of exponents, so we have the power of powers. So I want you to check out the first 2 examples, and then you try the next 2 examples. For example 1, we are given the expression 2 cubed the quantity squared. In this example, our base is 2 cubed and our exponent is 2. That means that when we apply the first rule, if we expand it, we will have 2 cubed times 2 cubed. But we can still expand 2 cubed and 2 cubed. So 2 cubed can be written as 2 times 2 times 2, and the other one can also be written as 2 times 2 times 2. So when we rewrite that as an exponential expression, so we will have 2 raised to 6. Now, let's continue with example number 2. We have x raised to 4, the quantity cubed. Just like what we did for the power rule, let us expand first. So we have x raised to 4 times x raised to 4 times x raised to 4. So we multiplied our base by itself 3 times since our exponent is 3. After that, we can expand each term. So x raised to 4 here can be written as x times x times x. The next one, x times x times x. And the last is x times x times x. So when we count all of those and rewrite as an exponential expression, the result is x raised to 12. By now, I know that you have an observation. So do you think there is a way that we can answer 3 or the quantity 3 squared, the quantity squared? Again, 3 squared, the quantity squared. So instead of going over this long process, based on your observation, is there a way that we can answer it right away? Yes. So we can actually multiply our exponents, right? Let's look at example 1 again. So we have 3 and 2. The exponents are 3 and 2. So our final answer, the exponent is 6. It means that we simply multiply those exponents. But we had to copy our base, which is 2, and then multiply the exponents. That's what we did with example number 2. So we can copy the base x and then multiply 4 and 3, and the product is 12. That's why for example 3, here is the long process, but we can simply write or copy 3 and then multiply 2 times 2, and the result is 4. So 3 squared, the quantity squared, is equal to 3 raised to 4. And for example number 4, I know that you already have your answer. So the answer there is simply copy 2 and then multiply 2 times 3. So the exponent is 6. So for the power of powers, we have the rule an, the quantity raised to m, is equal to a raised to n times m. We are multiplying our exponents for this rule. Let's move on to number 3. The third law is the product of a power. So again, I want you to observe the following examples. So for example A, we have x squared times x squared. When we expand x squared, it can be written as x times x. The same thing with x squared, so it is also x times x. So when we rewrite that as an exponential expression, so our answer is x raised to 4. Okay, so here is example B. So we are also multiplying 2 cubed times 2 cubed. So let us expand them. And we will have 2 times 2 times 2 times 2 times 2 times 2. And when we simplify that, we will obtain 2 raised to 6. So what is your observation based on these two examples? Okay, so again, here is example C. So I want you to try to look at the similarities or look for a shorter way for us to skip this method or to skip this step. Okay. So what did you notice about the bases of the expressions we are multiplying? So the bases are actually the same, right? So we can just copy the base. After that, what did we do to our exponents? So for example A, we have added 2 and 2. That's why we obtained 4. For example B, we also copied our base, which is 2. Again, you have to make sure that the bases are the same. Okay? This only applies if the bases are the same. And then we add 3 plus 3. So the exponent is 6. And for example C, our base is x. And we add 6 plus 4, which is equal to 10. So that is 4 product of a power. If we are multiplying terms which have the same bases, so we simply copy the base and add their exponents. So here is the general rule. So a raised to n times a raised to m is equal to a raised to n plus m. For number 4, we have the quotient of a power. So let us simplify the expression below using the first law. What again was our first law? That's right, the power rule, or n times. So to simplify this, we have to expand. 4 raised to 7 can be written as 4 times 4 times 4 times 4 times 4 times 4. And 4 raised to 4 can be written as this. After that, we can cancel the 4 fours. And we are left with 3 fours, or 4 times 4 times 4, which can be written as 4 cubed. Okay, next, let's try this example. So what do you think is the result when we divide 3 raised to 5 over 3 cubed? So let us again expand. If we expand that, we will have 3 times 3 times 3 times 3, and then 3 times 3 times 3, and then we will cancel. But there is a shorter way for us to answer. Let us observe our first example. So in this example, we can just copy our base. So again, just like in our previous rule, the base should be the same. So they have the same basis, which is 4. And then what did we do to our exponents? We subtracted them. So 7 minus 4 is equal to 3. That's why the result here, or the final answer, is 4 cubed. With that as a clue, we can do the same by copying the base, which is 3, and then subtract 5 minus 3, and the result is 3 squared. For example B, so again the bases are the same, so we copy 4 and then subtract 3 minus 2, and the result is 1. But when the exponent is 1, we don't have to write it, so we simply write 4. And how about example C? So of course that is 5, and then 3 minus 1 is equal to 2. So the final answer for C is 5 squared. Okay, so those are the answers. And let's continue. Here is our general rule. So if we are given a raised to n over a raised to m, we simply subtract our exponents. Let's continue with law number 5. For the fifth law, we have law for zero exponent. Let us simplify the expression below using any law that we've discussed. So what is the result when we divide 2 cubed over 2 cubed? Let us use first the previously discussed one. So we have 2 cubed over 2 cubed, so that can be 2, and then 3 minus 3 is equal to 0. Am I right? Yes. How about if we use the first method wherein we will expand? So let us check. So we have 2 cubed over 2 cubed. And if we are going to expand that, we will have 2 times 2 times 2 over 2 times 2. So times 2 times 2. And we can cancel. After that, we are left with 1. From that, we can say that 2 raised to 0 is equal to 1. They are similar. 2 raised to 0 is equal to 1. So law for zero exponent simply says that a raised to 0 is always equal to 1. Again, so in here we have 2 raised to 0. So if the exponent is 0, it is simply equivalent to 1. But a should not be equal to 0. Remember that a should not be equal to 0. Okay, so here are some examples. So 2 raised to 0, b 100 raised to 0, and cx raised to 0. All of those are equal to 1. So remember, for law for zero exponent, if the base is, or if the exponent is 0, then it is always equal to 1. Okay? And we move on to the last law, which is the law for negative exponent. So let us try simplifying the expression below using any law. Okay, so here is the first law, or first solution. So we have 3 squared over 3 raised to 4. We use the first law, which is the power rule. So we've expanded 3 squared and we obtained 3 times 3. For the denominator, we have 3 times 3 times 3 times 3. And then we cancel what we can cancel. So 3 and 3 can be canceled. So for the numerator, we are left with 1. And for the denominator, we are left with 3 squared. And using another method, which is the law for the quotient of a power. So we've learned that if the bases are the same, we simply copy the base, which is 3, and then subtract our exponent. So 2 minus 4 is equal to negative 2. From those two solutions, we can say that 1 over 3 squared is actually equivalent to 3 raised to negative 2. So that is actually what the law for negative exponent tells us. Okay, so here are some examples. So 2 raised to negative 1 can be written as 1 over 2. How did that happen? So we know that 2 raised to negative 1 can be written as 2 raised to negative 1 over 1. Now to apply the law for negative exponent, we get the reciprocal. So we have 1 over 2 raised to 1. So for our exponent to become negative, we have to get its reciprocal. So the reciprocal of this is 1 over 2 raised to 1, or again, since it's okay if we will not put 1 as an exponent. So 1 over 2, or 1/2, is the answer for letter A. For example B, so we have 5 raised to negative 2. So again, 5 raised to negative 2 is similar to 5 raised to negative 2 over 1. So the reciprocal of that is 1 over 5 squared, but for the law for negative exponent, we simply change the sign of our exponent into positive. So we have 1 over 5 over 2. 1 over 5 squared. And for example C, we have x raised to negative 3. So get the reciprocal to make the exponent positive. So it can be written as 1 over x cubed. Here are more examples for the law for negative exponents. So for example 1, we have a over b raised to negative 1. Since the exponent of a is 1 and the exponent of b is negative 1, so we have to get its reciprocal. It will move to the numerator. That's why it can be written as a times b or ab. For example 2, we have 2 over x raised to negative 5. Since the exponent of 2 is also positive, so it stays in the numerator. Only x raised to negative 5 will be moved to the numerator. That's why it can be written as 2 times x raised to 5. For number 3, we have c raised to negative 2 and d raised to negative 1. So since this is negative, so for it to be positive, it must move to the denominator. So we have c squared, and then the exponent of t is negative. So for it to be positive, it has to move to the numerator. Okay, so it is d raised to 1 over c squared, or simply d over c squared. For example 4, so the exponent of y is negative. That means that it moves to the denominator. Okay, and the exponent of 4 is 1, so it stays in the denominator. That's why y raised to negative 2 over 4 is equal to 1 over 4y squared. And lastly, for example 5, we have x times y raised to negative 2 over 6 raised to negative 2. So in here, only y has the exponent negative 2. So y raised to negative 2 should move to the denominator for it to be positive. So we have y squared. And then 6 raised to negative 2 should be moved to the numerator for its exponent to be positive. So we have 6 squared. And x remains in the numerator since its exponent is positive 1. So the final answer here is 6 squared x over y squared. So the general rule for the law for negative exponent is a raised to negative n is equal to 1 over a raised to n. That ends our lesson on laws of exponents. So again, our 6 laws are the power rule, or n times, the power of powers, the product of a power, the quotient of a power, the law for zero exponent, and the law for negative exponent. I hope that you continue to watch our next lesson. Goodbye.